All right, class.
Yes.
Hello, good afternoon. Say hi.
Hi.
All right, this is my 7th hour that we're recording because they're so awesome. I was like, yeah, 7th hour, we're going to do this, right? So, we're continuing from yesterday's notes. Hey, that one's just a little bit late. No, yeah, a little bit late, okay? All right, okay. So, yesterday we went through and we made it through all of this right here on the front page. Okay, so I'm going to go back a little bit. So we did all of this on the front page. Now we're on the back page. So right here. So where it says 8.3, and this is again page 15 in my notebook. So I know all you people are following along, and everyone in here is amazing. That's why I wanted to. Yes, that guy. You gonna tell me? Okay, but that's not the part that I'm trying to get at yet. All right, we've done this same thing before. This was actually one of our practice problems from a previous lesson. It says triangle can be created by starting with an equilateral triangle, breaking a triangle into 4 congruent equilateral triangles, and removing the middle, starting from a single black equilateral triangle. Let S be the number of black triangles in step N. Define S of N recursively. All right. So first, let's go through and actually figure out how many we have. How many black triangles are in the first one?
1.
Very good. How many is in the second one? 3. Third one? 9. 27? Yes. Say yes.
Yes.
Okay, now, definition. So I know everyone's paying close attention right now because this definition is super, super duper important. Recursive means you have to have the previous number. Recursive means you have to have the previous number. So, in all of our definitions, the previous number, how would I state the previous number? N minus 1. There was my N minus 1. So now we are going to do this recursively. So it's going to be S of N is equal to. So if I'm doing this recursively, how would I do this? S of N minus 1, right? I heard that. And then what do I do? Times 3. There we go. So that is the recursive. Recursive means I have to have the previous. We're going to talk about other things that are not recursive. Okay, not recursive implies that I don't have to have the previous one. So we have defined this in recursive. So now, what values of N am I using here? Yeah, right? So I'll start off with 1, right? So in this case, I would have to have the first one given to me, right? In this case, I have to have the first one given to me. So my pattern for N would be N has to be greater than equal to, not 1, 2. The reason why I say 2 is because you're going to plug in 2. If you're doing recursive, that means you have to have the previous value. So the first one is always got to be given to you. Okay, the first one's got to be given to you. So in this case, we're going to start plugging in for 2. You don't plug in for 1 because 1 is given to you. You start with the second one, then the third one, and so on. Okay, that's the whole meaning of all that. Now, I'm going to take, before we actually get into all this other stuff, and I'm going to show you guys what is non-recursive. So how do I start this out? My first number is 1. Okay, so I'm going to start 1. How do I get to the second number? Times 3, right? Okay, so I multiply by 3. How do I get to the next number? Times 3, right? How do I get to the next number? Next one. And next one. This is super important to understand. If it is repeated multiplication, what is that actually going to be? I heard it over there. Exponent. Very good. Repeated multiplication is an exponent. Repeated addition is multiplication. So repeated addition is multiplication. Repeated multiplication is exponent. Right? Okay. So we're going to go through this, and I'm going to show you guys how this is set up. So I'm going to set this up in a basic sense right here. So in this basic sense, I'm going to start off with, I know that this would be S of n is equal to 3. Now, if it is an exponent thing, right? It is an exponent, so that means that I'm going to put my n right here, isn't it? And there is another rule that I have to have. Okay, there's something else that has to go with this, because if I were to plug in my first one, what is 3 to the first power? 3. Is that my first term? That's not my first term, is it? Is that little thing still up there? No, there we go. Okay. No. So I have to make it so that my first answer is going to be 1. Now, there's an identity that I've mentioned before, which is super important in this case. Anything to the 0 power, so 3 to the 0 power is 1. 3 to the 0 power is 1. Anything to the 0 power is 1. That's super important. How would I make this one say 1? Wouldn't that be n minus 1, right? So let's define our n's. So in this case, n has to be greater than equal to 1. Watch this. There's a reason for that. On my first term that I'm looking at, it'd be 1 minus 1 is 0. 3 to the 0 power is 1. There we go, I get that one. Now my second term, 2 minus 1 is 1. 3 to the first power is 3. And if I wanted the third term, so it'd be 3 minus 1 is 2. What is 3 squared? 9. Fourth term, 4 minus 1 is 3. 3 to the third power would be 27. So this is going to be explicit. Okay, this is an explicit rule for this one. Okay, it is exponential, it is explicit. That means I do not have to have previous numbers. I only have to have whatever term that I'm looking for. So the previous number thing is going to mess me up later on if I don't want to have to do all the way to 100. If I need the 100 term, I don't want to have to do it 99 times, because that means 99 of the previous terms. All right, so let's see. For this one, I'm going to show you guys, and you guys are going to help me. Since I already did this, it's going to be S of n is equal to 3 to the n minus 1, where n is going to be greater than equal to 1. So you guys are going to, we already did this, you're going to write in the 4 terms of this one, and then we're going to do this one over here, where S of n is equal to 3 to the n, where n is greater than equal to 0. So I'm going to give you guys a moment. I want you guys to fill in your numbers for both of these. Fill in the numbers for both of these. So you have to start putting them in. So everyone is doing it. Can you what? Yes. I think you're next. All right, so for this one, we already did this. This is my 1, 3, 9, and 27. So this one over here, what is my first term going to be? 1. Because it states that n is going to start at 1. Oh, I'm sorry, start at 0. My n is going to be 0, so I plug in 0. So 3 to the 0 power is 1. And after that comes 1, right? So 3 to the first power is? 3 to the second power is? 3 to the third power. Hey, look. Is it exactly the same? So what is different about these two? That -1 right here. The -1 is when I plug that in, I had to get 0 for my exponent, right? And so I started my n values. So this n value right here, these are super important. That tells me where I'm going to start plugging in at. That means that I'm going to start at 0, or I'm going to start at 1, or I'm going to start at 2, because the first one might be already given to you. So let's look at this next one now. So here are two sequences, right? An explicit rule for the nth term for both in simplified form. Now, what that means is, okay, I want you guys to do it like this. So this is how my other class actually was very successful at getting to this. Figure out what it is, kind of like I did on over here. Figure out what it's doing, and then you're going to try and write a definition for this one, a rule for this one. Okay, so you and your partner together are going to do these two right now. So I think everyone here should have a partner. Yeah, basically. All right, so I'm going to turn the light on. So I want you guys, I'm going to give you guys a couple minutes. Please, please, please. You're working on that. Not staring at me.
Just adding, including
So which one of those is right?
They're both the same. There's not wrong on that one because they give you the same pattern, right? The whole point was how do you start it? The n values are super important. So whatever you state that the n values are going to be, that's the numbers that are going in. No, you're supposed to be working with your partner. Jack, Jack. What's up? I don't like the second one, and I don't like the first one. The second one is close, but the first one is. No, we don't want. Okay, you got recursive. This means previous term, right? We don't want previous term. Right, you're not using the n minus 1. Yeah. N minus 1 is previous term. You're not using that. Okay, so this is good. So what does this mean now? So what would the definition of that be? The rule for that? No, because this is recursive. This is previous. It'd be something like these ones over here. You guys could look at the previous page. The previous page actually has it too. Right here. Yeah. You and your partner are working on trying to answer these right here. Get a definition for this. No, no. You're actually trying to get a rule, kind of like these are rules, right? Kind of like these are rules for, and those are also for these patterns. Oh, yeah. It's a start. It's a start.
You're on the right track.
Better, but write out more. Write out more of that. Write out more. See what you get, okay? Because hopefully you'll be able to see it. Okay, yes. Yes, you're on the right path. Really close. But don't like that. Almost. Almost. Okay, so you're adding 2, right? Okay. So that one's, you're getting close there on that one. You're really close. You're super close now. Check your numbers. Check your numbers because they have to go back and match it. Remember, if you plug in n, you have to get those same numbers in the sequence. Huh?
I don't know if I'm correct.
Okay, that's good, but that's not the rule for that one. I need a rule. Give me a rule.
You said you can't use n minus 1, right?
No, because that's recursive. All right. Anyone have an answer for this one? Yes, that guy. Go ahead. Wait. Hold on. Before I get your answer, because I know it's right. Okay, I'm gonna watch it. I want you guys to see this. Now, if I'm writing this out, where did I start at? And what did I do? And then I. So, repeated addition is just what? Multiplication, right? So, let's say this is going to be, I'm going to call it S of n. Go ahead. What? 8 plus what? 2n. Now, define what n's I'm using. How do I get my first term? You said 1? Okay, so that means starting at 1. So, what is my first term? My first term is 8. So, if I plug in 1, is that correct? Nope, it's not. How would I make that correct then? Then what? Not 7. Okay, listen, please. Listen. All right, going back to what he was saying. If I plug in 1 right here, what do I get? I get 10, don't I? I get 10. Is that what I'm supposed to get?
Oh, you start at 0.
You start at 0. Thank you. That's what I'm looking for. You would start at 0. Because on this case, I would start at 0 for n, because now if I go 0, that gives me 8. If I go 1, that gives me 10. If I go 2, that would give me 12. Does that make sense now? Better sense? No sense. Less sense. Say it again? Okay. So, n is the number sequence I'm using, right? So, are you okay with this right here? Because it's 8 plus 2n, right? Because 8 is my starting, and it goes up by 2's, right? And so if I start at 0, so when n is 0, 2 times 0 is 0, right? So my first answer has to be 8. If I started at 1, it'd be 8 plus 2, right? And that would be 10. So that's not my first term, is it? That's why I had to start this at 0. Does that make more sense? Okay, so now let's look at this one. This is almost the same as what's up here. Almost. Anyone have one for this? That guy again. Good job, that guy. What do we got? So let's write it out first. This would be, if I'm writing it out, it would be what? 3 times, 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 times. Okay, so repeated multiplication is exponent. So what would I write of this? S of n, 3 to the n, right? Okay, now let's define it. What n's am I using? N?
N is greater than or equal to 1.
1, very good. Because my first term is 3, right? My first one is 3. So if I were to plug it in, 1, 3 to the first power is 3. If I would have did 0 here, 3 to the 0 power is 1. That's why I was saying this is not the same as my previous setup here. So it was different. Does that make sense? Okay, so now, is everyone good? I'm about ready to move on. Yes, go ahead.
I still don't get the 0.
You don't get the 0 thing?
Yeah.
What 0 thing?
Like 2n equals 0.
This one right here?
Yeah.
Okay, so what this means is the numbers I'm using to plug in. So if n, so watch this, so s of 0 equals 8 plus 2 times 0. That's what that means. So what is 2 times 0?
2 times 0 is
0 plus 8.
8. Oh,
So that's my first term. That's what I'm trying to get at. All right?
right.
So let's take a look at the backside over here. So what we just did is, right here, recursive. So while defining a sequence recursively works to calculate the current term from the previous term, if we want to calculate, say, f of 100, it would mean calculating all the terms up to 99 to get there. You wouldn't want to do this 99 times, would you? No. Better way. And that's where it actually comes with the, right here. So if you notice, if I were to ask you what is the 10th term here, instead of actually doing it over and over and over again, right, I could just do of 10. That would be 3 to the 10th power. And that would give me the 10th term on that one. In this case right here, if I were to ask for the 10th term, I would plug in what? 9. Because I'm starting my count at 0 here. Because 0 refers to my first term. And it would be the 9th. That's super important. That is on the test. Hint. Test question. Alright, so. Okay, listen. I'm going to let you guys have the rest of the class here. You guys are going to finish up page 14. Okay, front and back, which is a whole lot of these. And don't forget, like, share, and subscribe. Don't forget, leave comments, all that good stuff.
And good one.
Yeah, there is a PayPal option here.